Hello, everyone. I want to thank you so much for joining our webinar today, Run Models Faster and Get Results. Good morning or good afternoon, depending on where you are in the world right now. And again, thank you for joining. We like to start every webinar that we have with a safety moment. And since we're going to be talking about floods and flood manager today, I thought it would be appropriate to start with a flood warning. So what do you do if a flood warning is issued? Well, number one, you find safe shelter right away. That would be the first thing. Do not walk, swim, or drive through floodwaters. I'm sure you've heard, turn around, don't drown. Remember, just 6 inches of moving water can knock you down, and 1 foot of moving water can sweep your vehicle away. So stay off of bridges over fast-moving water, and depending on the type of flooding, evacuate if you're told to do so. I'd like to go over who we're working with today. First of all, my name is Susan Marlow, and I am the Director of Client Solutions for our Stantec IO, which is our digital commercial products. I have with me today Katherine Osborne, who is a Senior Associate in Business Development, also working with Stantec.io. Katherine has 13 years of experience in water resources engineering, primarily supporting the FEMA Risk Map program. And Brandy Little, who is our Director of Project Management, has over 17 years of FEMA floodplain mapping experience and currently serves as the product manager for Flood Manager, the product that we are showcasing today. Our featured topics today will be talking about some of the pain points that you may have with modeling that if you are a modeler, you will potentially have experienced. We'll then do a live demonstration of Flood Manager and let you see it in action, see how it works. And then we'll talk a little bit about leveraging the cloud and the parallel processing. And of course, we'll have questions and answers all along the way. If you have questions today, please put those in the chat as we go, or the question and answer session as we go. Also, we will be recording today's session, and we will be providing that to you at the end of the session. We will also provide you with a certificate for professional education credits. And so with that, I will turn it over to Katherine.
Thank you so much, Susan. So before we dive in, I just wanted to take a few minutes to highlight why we're hosting this webinar today. Floods are the most common and among the deadliest natural disasters in the U.S. today, and the number of flood events is rising across the country. As engineers, scientists, and planners who live and work in the communities around the world, we've seen firsthand the devastation that can result from these events. We've worked with many agencies to build resiliency to such events and have also aided in recovery efforts in the aftermath of a flood. We realize that tapping into advanced technologies could make a significant difference in helping our communities prepare for and mitigate the effects of a major flooding event. So we tapped into the power of our science, engineering, and design expertise, brought in data scientists and software developments, and UI/UX designers. By marrying people with the power of technology, we believe we can make a difference, help our communities prepare, and lessen the impact. This thinking drove the development of our Flood Suite. So this slide shows an overview of our Stantec.io Flood Suite products. So with similar names, I think it's helpful to show how each product is related and different. It's important to note that each product may be used independently. For example, we may have a client using Model Manager, but not Flood Manager or Flood Predictor. So to give an overview of each, Flood Manager optimizes physics-based or traditional modeling. Model Manager provides a solution to organize, store, and share finalized modeling data sets. This is especially helpful as our physics-based models have become more complicated and take up more storage space. And then Flood Predictor uses machine learning to make flood predictions trained off our trusted physics-based models. I wanted to touch on some modeling pain points some of you may be experiencing. Many of you are likely performing probabilistic and two-dimensional analyses, a shift from the traditional one-dimensional or binary analyses. These types of data and models analyze a larger area, increased number of hazards, scenarios, probabilities, durations, and intensities, which can provide more detailed and reliable results, especially in complex flow simulations. However, these models come with some challenges. Now, instead of minutes to run a model, it can take hours to days. Shown here is a typical 2D model with a runtime of 19 hours. Unfortunately, it can be difficult to plan runtimes on the front end because you really don't know how long a 2D model will take to run until it's set up. These models are larger, more complex, and therefore take more storage and time to develop, calibrate, process, review, and share. Another modeling pain point you may come across are the significant run times for multi-plan models. So this is an example from one of our users of a model with 47 plans. And so keeping all of those plans organized is pretty daunting as well. And then another problem you may have faced is model size and storage challenges. So you may be performing a balancing act regarding model size, meaning that the actual model footprint size and the storage size. So hypothetically, we could create models with smaller storage sizes by modeling smaller basins, but the caveat is it's more difficult to manage the increased number of models. So alternatively, instead of modeling those multiple subbasins, we could model the entire area in maybe one or a few models, and then we would have a lower total storage or the standard overhead created in those HDFs. So this is an example on the left here of one Huck 8 watershed model with around 750,000 cells, taking about 93 gigs. And then the second model example where a watershed was split into 10 sub-basin models, each ranging in size anywhere from 9 to 42 gigs. And the total size of the individual models collectively is 224 gigabytes. So there's a big challenge. And then sharing these models, of course, is another difficult challenge as well. So I've heard of teams that have been having to mail hard drives to try to compensate for this large model sets. And because of these issues, that's why our engineers here at Stantec have created Flood Manager. It's really to help address these challenges that you may be experiencing and speed up the process of these model types. So Flood Manager is a digital solution that allows for streamlined modeling, secure storing, and easy accessing of modeling data. So when combined, we can leverage the power of data to deliver in new ways. And I'm going to turn it over to Brandy Little, who is our Director of Product Management, and she'll demonstrate how Flood Manager alleviates many of these challenges that you may be experiencing. Thanks, Brandy.
Hello. Going to share my screen now. Katherine, can you verify when you can see the screen?
Yes, we're all good, thanks.
Okay. So Flood Manager is organized by project. So at the top level, we have the project. All users who are assigned to that project have access to models that are created within that project. So the engineer is still putting the HEC-RAS model together on their local desktop. When they're ready to actually run the model, you can come in, create a new model. So we'll do Muncie model test run, create. From here, the engineer is able to go to their folder that has all of the model input files. Those can be dragged and dropped into the browser where they are uploaded for this specific model. You're also able to give your model a description. So this can be anything that the engineer would like to call the model, just to be able to differentiate between each model run. You're able to select a compute cloud size to run that model and have a model run description. So do Muncie run 1. We currently support HEC-RAS versions 507 through 641. This is a Muncie base model 507, so I'll pick that version. Once all of your files have uploaded, your plans that are available for this model become available in the plan view here. You can select all plans to run or just specific plans if you only need to run one of them. We also have some post-processing built in. These are spatial exports for your depth grid, water surface elevation grid, velocity grid, as well as some shape files for boundary conditions, break lines, and 2D reference lines. So these are completed after the model run is complete and available with your output files. When selecting grids, we also have the user select a projection file for those specific grids. So this one is State Plane, Indiana. And then you can select a render mode option from that as well for your grids. We have a 2D post-process quality report. This is available for the 2D models. This I will show you shortly what one of those looks like, but you can select on the UI whether you would like that report or not. And we have some advanced settings around model run times that can be set by the user as well. So when the model parameters are all filled out, you queue the model to run. This is initiating the model to be run in parallel. So when you have more than one plan, we're able to run all of those plans in parallel instead of sequentially. So it's going to jump us over to our run window. As this is being created and running, you'll see the statuses here, and I've got one pulled up that I'll show you. So each one of your plans, this specific model was a model called Bald Eagle Creek. It has each of the plans listed out here. And so all of these are being run at the same time. So in the amount of time it takes your longest plan run to run, you can have the entire model run. So unlimited amount of plans so far. We do provide some details about each of the runs, so you can look at the start time, complete time. We have some output folders and the version that this model was run in. And then if there are issues and the complete status shows a success with error or specific errors for that plan run, we do pass along some of those messages in this output as well. During the model run, the user has the ability to download a standard output file so they can track the status of the model run. When the model is complete, we have the ability to download the log files to be able to look at each one of those plan runs and what was completed. We have the ability to download the full model set, so that would include all of your input files and your result files. Or you can choose just to download the result files. So these compute files only is a subset of, it's just the files that have changed during the run. This is super helpful when you have a very large terrain file or input files, and if you already have those locally, you might not need to download the full set, so you can save a little bit of time on downloading by just downloading the compute files option. We also have the ability to download the QA/QC files from here. And these save as options allow the user to select the location where they would like to save these files. If you have some super large models, I know we've had some that have exceeded the 100 gig level, so those are really nice to be able to do the save as and save them to an external drive or a different drive instead of your local downloads folder. So those options are available there. For the QA/QC, we have, this is a sample of one of the 2D QA/QC reports. So it does provide a summary of those plan files, your HDF files. It gives you a quick look at the percentage error volume accounting. It pulls together all your plan information so you can quickly see things that were set in the model, and provides the plan parameters, as well as a mapping of the boundary conditions. So this gives the maximum depth, minimum depth, and then cell locations with depths greater than 1 feet. So to help pinpoint where those areas are potential ponding on the edge, and kind of give you an idea from the engineer standpoint of where you can look for those. And then there's also a computational summary provided at the end. If there are some accounting velocity anomalies, those can be plotted and shown as well. So this is a sample of one of those. So it kind of pinpoints where that velocity anomaly is and gives you a graph of those as well. We also have at the project level the ability to upload some review files. So if I come back to my demo project that's currently running my model, I have this review file option. This takes me to a file storage location. So this is shared across the entire project. So you can upload your QC responses or checks at this location, and then everyone assigned to that project has access to these. So this has been super valuable in that review process on speeding the coordination of that up. Filling out these quality report checks specific to your model can also be made more efficient by using that QA/QC report and very quickly being able to answer some of those questions that you're looking for in the quality report. So it's definitely valuable from the coordination standpoint and making sure that that you're able to catch things early on in the process instead of having to send it over for review and then addressing later. So really aiming to solve that pain point of helping get the models to a more complete status even before it goes into review. We also have the ability to have this viewer option. So on the viewer option, if you had a model run, you can come in and actually select, if you selected some of those spatial exports, those are made available on this view. So this is the depth grid for a Muncie model run. We also have velocity water surface elevation available as well, since those grids were selected to be made. So those are available in this viewer just to allow the engineer to be able to quickly assess these before having to download the model in case changes need to be made. Those can actually be made if you have a geometry file or a specific file that needs to be updated or settings corrected. You can actually come in and replace the files in this view and then just update your run description and kick this off again, and it will use your new input files to rerun that model. So you're not having to re-upload your terrain or any of those large files that you have. We also have options here for downloading all of these files individually. So these are provided in zip files to download in kind of a larger grouping, but the engineer is also able to come to this agility output folder for their specific run, and they can look at the sizes of these files by selecting details. So you can get the size of the file before you download it if you're interested in that. You also have the ability to download some of those individual files if you want to get the depth grid or the velocity grid or water surface grid without having to download the entire model set. You can just download those from this file browser as well and pull them into your Esri instance or and whatever software you're using to look at those. And I think that kind of sums it up. Can hand it back over to Laura.
Great, thanks, Brandy. I appreciate that. So Flood Manager leverages the cloud and parallel processing to improve data management and speed. It's web-based and accessible anywhere. So anywhere that you have internet access, you can get on Flood Manager. The metadata provides a lot of details that you may need throughout a project, such as who ran the model or versioning. It reduces project delivery time. As Brandy showed you, there's that 2D quality report that you can run to provide consistent quality control. And this really helps identify those global errors, inconsistencies, anomalies for a better resolution on the front end of your development. And the best part is you really don't have to babysit this product. So you get an email when the run is complete. So Flood Manager is going to provide the most benefit to users who are modeling multiple models or plans at one time, or if they have those models with really long run times. And we thought it would be helpful to provide an example of potential time savings. So this is for a core model with 6 storms and 2 conditions for each, or a total of 12 plans. So if we ran that on an average individual workstation, this model took 96 hours or 4 days to run. And then using Flood Manager and the parallel processing feature, this model was run in less than 8 hours, saving approximately 3.5 days of runtime. So this gives the engineer more time to spend on quality control, finalizing models and deliverables. And you can imagine the potential time that could be saved on an entire watershed or project. And as Brandy pointed out, Flood Manager is particularly useful after you have developed one plan locally on your workstation, such as the 1% annual chance, and then you can use Flood Manager to run those additional return intervals or conditions. And Flood Manager can run an infinite number of plans for a model and the time it takes to run the longest plan on an individual workstation. So shown here is a case study for 2-dimensional modeling in Kansas. This example model would have taken about 59 hours to run all the plans sequentially, but however, using Flood Manager, the project team was able to run this model in about 12.5 hours. And this is another case study for the Iowa Department of Natural Resources. The DNR employs multiple contractors to perform engineering services in support of their statewide mapping program, and they've initiated a large 2-dimensional base level engineering assessment. So Stantec provides the program management to DNR for their cooperating technical partner program. The DNR is using Flood Manager to support the 2D BLE initiative. And this implementation has been successful, especially with the data management piece and the peer review process between those modeling contractors. So Flood Manager has allowed for expedited model runs, seamless quality control, and product completion. So any user on the team can log in and access the latest and greatest data sets for review and can share comments directly within the review file folder on that project in Flood Manager. So the consistency is that application of that 2D quality report run on all the models, and this has really helped reduce that time spent with that back and forth exchange. So with all the files available on Flood Manager, Stantec was able to transfer the finalized data sets to Model Manager and added a viewer for the DNR to share these data sets with community officials. Here is some feedback we've received regarding Flood Manager. This example is from one of our external users explaining how Flood Manager removes the need for purchasing high computing machines and provides a long-term solution with a slick interface. Other feedback examples that we have received are, I haven't had anything that it hasn't been able to run. Was able to run and download 100 gigs without any issue. It processes a lot of data. And customer support has been helpful in finding a solution to some of my issues. So that brings me to our resources. So we have several options to help get you started, including a how-to video, a user guide, support guide, common errors list, frequently asked questions, and that example quality report that Brandy showed you. We also have a best practices list. So it may seem a little daunting using the product, but I promise you it's very intuitive, and once you run one model, you know exactly what you're doing. So. And then we also have resources to support our current users. So we have versioning, update, email notification. So this really helps keep our users current on any updates. And if appropriate, we'll include help guides on new features that are included. We have links to help expedite access or new project creation. And then we have a help center where you can submit tickets. So these are categorized to help streamline response times, such as help tickets about your login or your account, if you have a question or problem. And then in addition to the help ticket, you can email the support email at any time. So we really pride ourselves in being able to get back to you quickly and resolve any issues you might have. But now I'm going to turn it back over to Susan for some concluding remarks. Thanks.
Thank you so much, Katherine and Brandy. Thank you for the demo, Brandy. And Katherine, thank you so much for those explanations and some of those quotes from our users. We're very excited about the product, and we hope that you've seen some benefits from it today. There's lots of ways that you can take advantage of the product. There are different processing speeds that you can choose from. I think Brandy was working with maybe the 16 core, and we've seen that to be maybe one of the best uses, and we'll help you work together. We'll work together with you to help you figure out which one is best for you and your models. But you can also access the quality report, as Brandy showed you, just by itself. So you don't have to run the whole model to get the quality report. We can do that just on its own if you want to use Flood Manager that way. But also these services can be a pay-as-you-go model. So as you run a model, you pay for just the one model that you run or the plans that you run for that particular model. And then we also have monthly subscriptions available if you're interested in a somewhat unlimited amount of plans for a particular time period. We can set you up with a subscription. So we have lots of options, and we're always open to customizing an option for your specific needs and are happy to discuss that with you. So with that, I will turn it over to questions. And Laura, are you taking the questions for us?
Yes, I absolutely can. We have a number of questions today in the questions box. Let me pull those open.
Okay, thank you.
And I will run through them. And thank you all for submitting some great questions so far. All right. From Danielle, we have the question, do you support programs other than HECRAS? For instance, we use ICPR in Florida. If this isn't supported now, are there plans to add additional models in the future?
We're always open to looking at new models. We have used HECRAS because that's what we've been doing for FEMA internally. So we're happy to look at, explore other models, and happy to do that even with you to determine if that's something that we can use. We definitely are interested in doing other models as well. So thanks for that question.
All right, our next question from Thomas. Are status messages from HECRAS propagated from HECRAS to the Flood Manager? Sorry, I just need to pull this screen open. It's cutting off the question. To the Flood Manager UI while the model is actively running.
I think that would be a question for Brandy. Can you answer that one, Brandy?
Yes, I can. So while the model is actively running, you're able to download the standard output file. So that's available on that output tab during the model run, and any messages will be provided in there. So we did recently in recent upgrades just add some ability to pass those messages over. So some do get carried over to the complete message in the details, but that's after the run is complete. But during, you can check the SD out file, the standard output file for those.
Thanks, Brandy.
Perfect. Thanks, Brandy. And we have another question that I believe is also for you, so don't go anywhere. What if the model files that are uploaded are incomplete? For instance, RASMAT file references a missing DEM or Manning's N layer in a completely different directory. Does Flood Manager catch that up front?
Yes, so when files are missing, one of the messages that we actually pass over now in that details is that there are potentially missing files. In that standard output file, when you download that, or the log file at the end of the run, you can actually look at that file, and it will typically have it included on, that the model wasn't able to find the terrain file, or if the 2D area, if the terrain doesn't match, cover all of the 2D area, like those same messages you get from HECRAS, we are able to provide those in that log file at the end of the model run.
Perfect, thanks, Brandy. Next question from Ryan. Is there a way to programmatically run or access models and results?
I would say that's for you, Brandy, as well.
Can you repeat that question?
Absolutely. Is there a way to programmatically run or access models and results?
So I think that is if you are on the project. So if you are on the project, those are going to be, it's still a manual upload of each model. So it's not currently, we cannot programmatically like start one after another or anything like that. It's the user uploading those model files and running them. I'm not sure if that quite answers the question. So my contact information is provided here on the screen, my email. If you'd like to email me that question, I can provide a little more detail.
Awesome, thanks, Brandy. Next question from Roshan. Are we able to share the software demo or a version of it with attendees?
Yes, so if you are interested in a demo or trial account, you can reach out and we can get you set up to try Flood Manager.
And just to add on to that, we will be sending an email following the webinar today with the link to where you can access the recording of this presentation along with a certificate of attendance. And these links that you see on the screen now, we will obviously, it's a little hard for you to click on them when they're in a webinar, but we will provide all of these links in the email that we send to you all. So you'll be able to very quickly get to our request to demo page or contact any of the individuals that you've heard from today. All right, next question from Sai. How are final files such as output DSS.prj handled when running multiple plans?
Yes, so all of those final files, when we're running multiple plans at the same time, the very last step in that output is a merge process. So all of those files are merged back to complete one full data set that is downloaded for that specific model. So you're able to run all of the plans and then those get merged at the end for the DSS and all of the output files.
Thanks, Brandy. Next question. And Susan, I think this one might be for you or Katherine. What is a typical cost for a one-time run, say 16 core on Flood Manager?
A single plan run is $50. So if you have multiple plans within your model, then it's $50 for those. So that's the price on a pay-as-you-go basis. And there's discounts for multiples of those, and we can work out if there's a certain number that you want, that we can work out some discount pricing for multiples of those. If you have enough that you want to have a subscription, that might make sense, but we'll work with you to see what's the most economical for your particular situation.
Good. Next question from Raja Raman. I did not understand the runtime savings achieved that we discussed on slide 14. Could we explain that again? And I'm actually, Katherine, I think you overviewed that slide. I'm going to see if I can get us back to slide 14 so that we can take a look at that at the same time. I think it was probably this one. Maybe this one. Is this? No, that's slide 7. Hey, look, there are numbers on the slides. That's fine.
Sure. So basically, this is just showing the power of parallel compute. So on an individual workstation, when all these 12 plans were run sequentially, the runtime of the model took about 4 days. But when we upload that model and run it to Flood Manager, all those 12 plans are run in parallel at the same time. And so when you do that, it takes less than 8 hours. And that time saving is shown there. Hopefully that made that a little more clear. So as we said, in the time it takes to run one plan on your individual workstation, that longest plan run is the time you can expect it to run in Flood Manager for an infinite number of plans.
Awesome, thanks, Katherine. And Rajaraman, if you still have questions about that particular topic, you have Catherine's email, but you can also add a clarifying question in the Q&A box, and we will absolutely continue. Oh, that just popped right out of slideshow mode. Let's toss that back in there. And let me go back all the way to the end where we were. There we are. Okay, next question from Travis. How long does it typically take to incorporate new versions of HEC-RAS after they're released?
I can take that one. Typically, as soon as we we determine that there is a new version, we start to add that to our next release. So I think the quickest we've turned one of those around is a couple days, but typically it falls in line with when our next release for the product is. And so that's typically, can be anywhere from a couple days to 2 weeks, depending on the release schedule.
Next question from Rue. Is Flood Manager capable of generating other result layers, such as depth, velocity layer from a certain time of the profile?
Currently, we are only supporting just those base grid exports from RasMapper. So that would be something we could look at adding in the future as a new feature. We have not looked at it currently.
We have a question here regarding cost from Jennifer. What is the cost? I'm just going to take us back to the cost slide, and Susan, let you cover that, if you will.
Sure. A single plan run is $50, and depending on how many plans you have in your model would be dependent on how much that would cost. And like I said, we have discount pricing for multiple runs or large volume of runs, and then we also have kind of an unlimited subscription pricing per month if you're managing a program and you have a lot of people running multiple programs like we have in Iowa. So in Iowa, they have multiple contractors running multiple plans, doing it on a regular basis, and so they're under a subscription basis. But even internally, we have a lot of internal users. I don't know how many internal Stantec people we have on the call, but on our internal runs, those are typically done as a pay-as-you-go, and we can help you determine about what those are going to cost up front if that's something that you need assistance with.
And I can add to that too, that our pricing is tied to the core selection. So if you see on the screen there, the 8, 16, 32, so those are per 12-hour run times for the specific compute. So it's a little less for the 8 core and a little more for the 32 core. So I think that's, if you're interested in getting more detailed pricing, you can definitely connect with us and we can go over that with you.
Awesome. Thank you, Susan and Brandy. Next question from Byron. Can you speak to, actually, we've got 2 questions from Byron and Cy that are very similar, so I'm going to group them together. And it's around data privacy and security, as well as where the models are run. So I'll toss that over to whoever wants to answer it.
Yeah, I could take that one. So we are using Azure to run these. So the application itself is fully Azure. So when you set up a new project, we have that all of your model files are stored in Azure Blob storage. So those are retained for the extent of your project. So all of the security and implementation that comes along with those Azure implementations are relevant here. We currently have a soft delete of 14 days. So if a file or a model is accidentally deleted, we can restore that up to 14 days.
I'd like to add one other thing to that on the security side of things, because as we were developing Flood Manager, we had to pass a pretty rigorous set of internal IT standards and security standards just in order to launch the product. So we have some pretty intense internal security standards that we had to pass in order to make the product available for our outside users.
Perfect. Thank you for that. Next question from Azeta. What happens if you're using Flood Manager and the model gets some sort of error and it fails to run completely? Are you still charged? Do you still pay for a model that doesn't work?
So currently our pricing is based on the success of a plan. So even if a specific plan has an error, if it has an error, you are not charged for that plan, but you are provided feedback on why that plan erred with the log file. And the merge will still complete all of the successful plans, and that's what your bill is based on the per plan pricing of a successful plan run.
Next question from Bamsey. Are these servers Linux based or Windows based?
They are Windows based.
Thank you. A nice simple question. From Yong, what's the difference between your service and the AWS cloud computing service?
So we are using Azure Batch on the back end for the compute service. So I'm not super familiar with the AWS piece, but I think the biggest difference would be the amount of time that has gone into creating the user interface and the ability for those users to upload their files, set the parameters. There's a lot of customization that has gone into that, and we've taken a lot of our HECRAS engineers' feedback in the features that would be valuable to them in the process, and then allowing for that coordination based on the overall project needs. So you can definitely accomplish what we've accomplished with AWS, I'm sure, but that would be kind of the back end piece of it. So we're using Batch currently to run those plans in parallel.
I would also add that the quality report and the visualization of the plans and things like that, the ability to parallel process and then merge them all back, that's also unique to Flood Manager. So as Brandy said, that the back end processing might be the same, but all the different steps along the way to make it all work are things that we've done specifically for Flood Manager.
Okay, our next question comes from Sai. Can we run Linux-based HECRAS simulations, or are the compute instances Windows-based?
The compute instances are Windows-based. We currently do not support the Linux-based.
Thank you. Next question from Suyag. How does Flood Manager compare to Flood Cloud, which is available in the market?
I might have to get back to you on that question because I'm not super familiar with Flood Cloud currently. So if you could, Laura, pass me the contact information, then we can look into that.
Yep, absolutely. And for right now, our final question, unless anybody else adds more to the Q&A box here, can we add custom post-processing steps?
So currently we do not have custom post-processing. You can submit a feature request through that support portal, and we will consider those in the feature backlog. I know that's how we got to the shapefile exports for the boundary areas and 2D reference lens, is because a user came to us and said, hey, it would be super valuable if we had this post-processing step included. So it's definitely possible as future features, but currently we do not have customized post-processing.
Okay. And that is our last question. So as long as I don't see any more in the 5 seconds that we have a thank you. And there are a few thank yous in here. So I'm gonna say a big thank you to the presentation team here. And Susan, I'm going to pass it over to you for any closing remarks.
Sure, thank you so much. Well, on screen, you'll see all of our contact information, and there's several ways that you can engage us. Number one, you can just go to our website and look at more information there, that sort of thing. You can contact any of us individually with questions. Our emails are there, and we're happy to engage with you individually. We will be sharing this recording with everyone that has attended the webinar today, and we would encourage you to share that with your network, share that with others in your organization. You can connect with us to set up a one-on-one demo. So if you have some very specific things that you'd like to talk about and you don't want to do it in this forum, we totally understand. We're more than happy to do a one-on-one demo with you. Again, we're happy to set you up with a free trial. We'll help set you up with a free trial account so you can run some of your own plans and in your own timing if you'd like to do that. And with that, I would just again say thank you. You will be receiving some professional education credits if they work for you, for your whatever organization you might be a part of. And again, thank you so much for your time today, and we look forward to connecting with you in the future. Thank you, everyone.